Hi students, good afternoon, good afternoon. Welcome, welcome, welcome. What we're going to do this afternoon is we're just going to explore a strategy called working backwards. So I want to introduce to us, and you already know her, my colleague, Mrs. Vassal Erskine, and she'll be joining with us as well. So remember, I want for you to post the name of your school in the chat and hashtag prep for pep. Also, you're free to go ahead and share the link so that your other classmates and your friends can join. We won't have a long session today. What we will be focusing on is how we can use the working backwards strategy when we're answering our ability test items, our performance tasks, and so on in preparing for our PEP exam. So let's dive right in. What is working backwards? Of course, you might want to ask that. What is working backwards? So, working backwards is a strategy, and it is where we start with the final solution and work back one step at a time to get to the beginning. So, in real life, we have different situations where we would have to work backwards. Do you have any? Can you tell me of some situations where you might need to work backwards in the chat? Just give me an example of where you might need to work backwards. All right. Someone says, Mia Lionel Henry says, trying to find a lost item. Definitely, because now you're thinking about where you are and you're now thinking about you're retracing your steps back to your starting point to figure out where you would have lost the item. All right. Abigail says having to pay some money at the store and then they only pay you the total. All right. So finding someone's age. Uh, so I'm seeing Abigail saying, and you when you have more money than you expected. Someone says subtracting. When you're adding in a question that asks you to find the beginning number, and these are definitely counting backwards. That definitely. Um, oh, making an engine work again. And Anicia Johnson, great. Definitely. And these are some examples of when we are working backwards. No, let us think about when we're going to make our uniform. So September is coming and we might need to go to the dressmaker, and make our uniform. But first, especially if it's a new school, you will need to get the pattern from the school. When you get the pattern is telling you what your uniform should look like. However, when you go to the dressmaker or your dressmaker or your tailor might need to look at the pattern and tell you how much fabric you need. She'll also need to tell you how many buttons, she will have to decide how many buttons you'll need, zipper if any, and those different things. So that is one example of working backwards. You have the design and you know that at the end all of these things will have to come together to create to make your uniform. Let us also think about building a house. when we're building a house, we know what our house would need 2 bedroom and I need them to be about this size and so on. That will help you to determine how much gravel you need to buy, don't it? How much sand, how much blocks, steel, and those things. It also will help you to determine uh how much the house will cost to build. And also you need to tell your architect what or you want your house to be so they can drop your blueprint. So those are some things that those are some real life situation that we need to take in consideration when we are when we need to really work backwards. And in mathematics we have situations where we must work backwards as well. And we're going to work on 2 examples this afternoon. So we're going to try out 2 examples of where we will need to work backwards. All right. So I'm seeing here building a house from design. When you're adding yes, if you're adding to the house, Abigail Tyson, definitely. All right. So, okay. So she's saying like upstairs. Right. Kalisha said we're thinking alike. Great job, guys. So definitely those are some things that we must take in consideration. And Adorks, JJ mentioned that blueprint for the house that we're talking about. So you guys are really on the ball. Tor S, I've been looking for you. So she says, knowing the area of the house and trying to find the length of each side of the room in the house. Tor S, I've been looking for you because I have a certificate for you, but I don't have your name. All right. So let's go to our first item here. So we have our first item, and I want you to look at what is happening here and tell us what you understand by this question or by this item. What do you think you need to do to solve this item? So I'm just going to go, thank you, Torres. So I'm just going to go ahead and read this for you. So Zion is 35 years younger than Dana. Livy is half of Zion's age. Jen is 17 years older than Livy. If Jen is 35 years old, how old is Dana? Take a couple minutes and all right, Peter Gay says we're going to add. All right, but and someone says we're going to multiply. Christian Stewart Gray says we're going to multiply. But definitely we might be doing some of those things in this question. But this is also an example where we must use that strategy to work backwards. Now, before we get into, yes, Mrs. Erskine?
All right, question. So we only know Jen's age, right?
Right.
How are we going to find Dana's age? Do we
Good
have to
question.
find out Levi's and Zion's age before we find out Dana's age?
That is a good question. That is really, oh, so then now you're Rodney saying we're going to work backwards. But we definitely are. But how are we going to do that? So Mrs. Erskine asked a really good question, and that should help you to go about solving your question. So I want for you to go ahead and tell me what you know. So you're going to tell me what you know from the question that we have. What is given? What do you know? Whose age do you know? Thank you, Jen K Entertainment. All right. So we know that Jen is 35 years old. Do we know the other? Okay, I see Livingstone saying that we know Zion's age. But do we know Zion's age? How could we find Zion's age? All right. So I'm seeing some responses here in the chat. So when we're working backwards, this strategy is good when we need to solve questions like these. We need to first think about what we know. And I'm going to go right ahead and underline what we know. So we know that Jen is 35 years old. All right. Whose age can we now find out after Jen's age? Whose age can we find out? All right, Reginaldo, Christy. We don't know Zion's age, definitely. But whose age can we find out? Okay, that Mika Downey says Dana is 1. Wow. All right. So someone says Livy is 17. How did you find out that Livy is 17? All right. Someone is telling me Dana's age. Let's talk about Livy's age. All right. So persons are saying, yes, we can find out Livy's age now. So we can find out Livy's age now because basically we need to move from what we know to what we don't know. So it says that if Jen is 35 years old, how old is Dana? Then we need to look for the sentence that comes before that to see if there's a relationship between Jen's age and Livy's age. Is there a relationship between Jen's age and Livy's age, Mrs. Erskine? You see any over there?
If I see any relationship
Between Jen's age and Livy's age.
yes, there's a relationship.
Okay, you guys on YouTube, do you see the relationship that Mrs. Bassel sees? All right, so definitely there is a relationship. That is the first age that we can go about finding out. All right, so we know that Jen is 17 years older than Livy. That means Livy is 17 years younger than Jen, right? So how old would Livy be? All right, so I'm just going to go ahead here. I'm going to annotate and I'm going to start
Or
from what we know.
what operation are they going to use?
See, look at that. What operation are you going to use? Please tell us what operation you're going to use to find this. All right, I see subtraction. Torres says subtraction. Charisma Williams says subtraction. All right. All right. Shame Speed says minus. I see a lot of subtraction coming in here. So what are we going to subtract? All right, so Siloni Maxwell knows the question I'm going to ask next. And she says we're going to subtract 35. We're going to subtract 17 from 35. And that will give us Livy's age. Do you agree with her? Do you agree with the person who said, okay, Reginaldo Chrissy says 35, take away 17. Do you agree with them? All right. All right. So that means then we can find out Livy's age. How old would Livy be? Thank you, Kimoya. How old would Livy be? All right. I realize that we're agreeing here. I see one person says that Livy is 22. So when we subtract the 17 from the 35, which we have agreed that yes, we need to subtract. So we have 35 and we're going to take away 17. So 7 from 5 we can't. So we need to get a tens to rename to ones. So we take 110 from 3 tens. We're left with 2 tens. That 1 tens is now 10 ones, which makes us have 15 ones. So 17 ones from 15 ones, we're left with 8. And 110 from 2 tens, we're left with 1. So Livy's age is 18 years. So I realize that you guys are really on the ball here. A lot of persons saying 18 and you're so correct. Thank you, Sabrina. So you are so correct if you say Livy is 18 years old. Whose age can we find next? I wonder if they know Mrs. Erskine. Whose age can we find next?
Let us see. I'm looking.
All right. All right. So persons are saying that Zion is 36, but I'm not really sure about that. I'm not really sure about that because you need to take your point. You need to explain why you think
Yes.
Zion's age is 36. All right. So persons are saying we need to find Zion's age next. And I think you're correct, you know. Yes, I think you're correct. You think they're correct, Mrs. Erskine?
Yes, they can show the working out in the chat as well.
Definitely. So you're going to show us your working out so we can find Zion's age next because Zion's age has some sort of a relationship with Livy's age. And now that we have Livy's age, we can find out Zion's age. So let's go ahead and you're going to tell me how you found out Zion's age. All right, Shame Speed says 18 times 2 equals 36. I'm seeing Ethan saying Zion is 36. Since Livy is 18, Livy is half of Zion's age. Yes, they said that to us. So 18 times 2 is 36. All right, all right. Zoe Friend says 18 times 2. Hope Sterling says is 36 because 18 plus 18 is 36. All right. Nashania is saying 18 times 2 equals 36. Charisma is explaining to say since it's twice, you have to multiply 18 times 2. All right. Kimani Williams, 18 times 2, 36. All right. All right. All right. So let's see what Torres has here. She has a lot of explanation. Okay, I think she went all the way down to Dana. All right. All right, guys. So definitely, it says Livy is half of Zion's age. That means, so remember, I know we're working backwards. Livy is half of Zion's age, but we don't know Zion's age. But if Livy is half of Zion's age, that means that Zion's age, Zion's age is twice Livy's age. So whatever Livy's age is, Zion's age is twice that. And that's why you guys have 18 multiplied by 2 to give us 36. And you are definitely correct. I see a lot of person here. They are way ahead. And that is good. But you know, we kind of want to keep the pace at a moderate level so that other persons can also benefit and understand what we're working with. So great job for those who are ahead. And, you know, thank you for waiting on us, keeping up with us. So now that we have found Zion's age, can we find Dana's age? Do you think we can find Dana's age now, students? All right. So Anicia Johnson said there are other ways. And you are so correct, Anicia, because someone said 18 plus 18. So, and that will also give us the response that we're looking for. So 18 plus 18. So you would do a little, what should I say now? Some little trial and you know, you'll try a few times, because if it is that you know your timetable really good, you know that you have to add 18 plus 18 to give you 36. Now remember that we're moving from what we know to what we don't know. All right, so Great job. There are more than one ways to solve this. And I like how you are exploring everybody's age. All right. So they're saying that Dana's age. But how will we get Dana's age? All right. So Ethan says you can find Dana's age. You would find her age by adding 36 to 35. Since he is 35 years younger, which would be 71. Therefore, Dana is 71 years old. Do you agree with them, Mrs. Erskine? Because they're saying a lot of things over here, you know. Do you think they're correct? Is Dana really 71 years old? You think they're correct, or you want us to wait a little more to see what they're saying?
They are correct indeed.
Whoa. So Mrs. Erskine says that you guys are correct. And that explanation that I just read from Ethan, you're so on point. So definitely, now that we have found Zion's age, we can find Dana's age. Because remember now, Zion's age, we have gotten some relationship between Zion's and Dana's age here. So we're able to now find Dana's age. So it says Zion is 35 years younger than Dana. And that means Dana is 35 years older than Zion. Am I correct, guys? Yes, definitely. So Dana is definitely 35 years older than Zion. And to find that, we need to add those numbers together. Zion is 36. We need to add 35 to 36. And as you guys said, Dana is 71 years old. Great. Great job. Great job. All right. So I'm going to leave this up a little while for persons to take a screenshot of what we're doing here before I clear the screen and move on to our other question. And remember, we're not staying long, so we want to finish up our other question. Thanks, Jordan Hanson. All right, so let's move on to our other question. I'm going to clear the drawings. We move on to our other question. So I'm going to go ahead and read this. It says that there are 4 students in the class. Carter was 15 kilograms lighter than Adrian. Gary was twice as heavy as Carter. Jeremy was 7 kilograms heavier than Gary. Jeremy weighed 71 kilograms. What was Adrian's weight? Or what did Adrian weigh? So that is what I want you guys to work out. Thank you, Shanna. That's what I want you guys to work out. So remember now, when we're working backwards, we move from what? What do we need to look for when we get a question like this? Because they're telling us a lot of different things here. What's the first thing we need to look for in this question? Thank you, Torian. Sterling. So you said that we need to find out which weight is known. All right. So, of Ms. Erskine?
Yes, so we work with what we know to find out what we don't know. So they have to remember that.
Great. We definitely have to remember that. And Torres says that. What did you say, Torres? What do we really know? Yes, Sophia Gordon. We have to find out what we know. All right. Rachel Griffith says what we know. Awesome. All right, so Sasha K. Harrison says keywords. And the keywords are also important because as soon as we find out our starting point, which will be our end point, then we can move on from there. So keywords are also important as well. So now that we have, tell us what we know here. All right, so Kelisha Morris Adams says Jeremy is 71 kilograms. Torres says we know that Jeremy weighs 71 kilograms. Welcome, Amaya Williams. All right. So now that we know that Jeremy is 71 kilograms, whose mass can we find out next? All right. I see someone says that Carter is 15 kilograms, but the sentence is not finished there. It says Carter was 15 kilograms lighter than Adrian. So yes, we can find out Gary's mass next because there's a relationship between what Gary weighs and what Jeremy weighs. So can you tell us what relationship? How can we find out um, what Gary weighs? So let's read that sentence that tells us the relationship they have. It says Jeremy was 7 kilograms heavier than Gary. How will we find out Gary's mass? All right, so Michelle says multiply. What are we going to multiply, Michelle?
Gary.
Thanks, Melissa. Thanks, Sanique. All right, so someone says we multiply 15 times 15. I'm not sure if I understand what's happening here. So we're going to find out what Gary weighs. And it says Jeremy was 7 kilograms heavier than Gary. So how is it that we need to find out Gary's mass? Someone says multiply. I'm seeing person saying minus and some saying addition. But what do we really need to do to find this out? Okay, I see Ashana FI says 71 kilograms take away 7 kilograms. And for that is definitely correct. So we need to subtract what Jeremy weigh, what Gary. So let us look at the relationship before. So Jeremy was 7 kilograms heavier than Gary. So we need to subtract that 7 kilograms from what Jeremy weighs. So if Jeremy is 7 kilograms heavier than Gary, it means that Gary is 7 kilograms lighter than Jeremy. And so we need to subtract that 7 kilograms from what Jeremy's mass is. So Jeremy weighs 71 kilograms. So we need to subtract that 7 kilograms from 71. And that will give us, let me see, Gary weighs 64 kilograms. Thank you, Sashari Vassal. Zephan Meyer says Gary is 64 kilograms as well. All right, so I'm going to put up what we have worked out so far. All right, so we know that Jeremy weighs 71 kg. And we said that to find Gary's mass, so Gary we say 71 kilograms. All right. So we know what Jeremy's masses and Gary's. So whose mass can we find out now? Let me see. Let me see in the chat. All right. Great job, guys. To find out Gary's mass, we need to subtract 7 kilogram from 71 kilograms. And that means Gary is 64 kgs. So who can we find out now? Whose mass can we find out now? Yes, we can definitely find out Carter. Thank you, Hope Sterling. We can find out Carter's age, Carter's mass. So how are we going to find out Carter's mass? Okay, I'm looking in the chat. All right, so Torres says Carter because Gary is twice the mass of Carter, which means Carter is half of Gary. Great explanation. I really understand what you just explained. So yes, we're gonna find Carter's mass because it says that Gary is twice as heavy as Carter. And that means Carter is half of Gary's mass. So let me write Carter is equal to, so how we're gonna find this out? Can you write that algebraic equation to show me, or even the expression? How we're gonna find this out?
Shakila has the answer.
All right. What did Shakila say?
64, what is 64 kg divided by 2
Definitely. So
equal
64. All right. All right. So that is so correct. So 64 divided by 2. And what would that give us? All right. So I'm seeing Ashana Fi saying 32. Rachel Griffith saying 32. All right. 32 kilograms. You're definitely correct. So now that we have found the Jeremy's mass, Gary's mass, Carter's mass, can we find Adrian's now? Can we now find out how much Adrian weigh? All right. So definitely we can find out how much Adrian weighs. So can you write that mathematical expression or even the equation or math sentence to tell us how to find out how much Adrian weighs? All right. So tell us. All right, Mariska Pinnock says Adrian is 32, take away 15 equals 17 kilograms. Let's look closely to what is happening here. It says that, okay, so Taurus is explaining. Carter is 15 kilograms lighter than Adrian. So Adrian is 15 kilograms more than Carter. Great job, Taurus. Great job. You're really on your way to stardom. I'm telling you, you're going to do so well in your PEP exam. And a lot of the other students here, you're going to do so well in your PEP exam. All right. So she says that we need to add 32 kilograms to 15 kilograms. All right. I see a lot of persons agreeing with her here. They're saying the same thing. All right, great job, guys. So definitely to find out Adrian's mass, we need to add 32 kilograms to 15 kilograms.
They must not forget to write the unit as well.
Definitely, I'm seeing a lot of persons here, Mrs. Erskine, not putting their units.
Yeah.
A lot of you not putting your units, and remember, your units are very, very important. So you must ensure that you have your units at all times. So we now know that Adrian weighs 47 kilograms. Tell me if you got this correct. Did you get this correct, students? Do you understand how to work backwards in situations like these? It looked like them understanding now, Mrs. Erskine. Yes, man. All
Yeah, they're
right.
bright students.
I know, right? All right, students. Yes, you guys have done so well. And you can ensure that you subscribe, because some of the times I'll be coming live with some of these little questions that will help you in your PEP exams without sending a notification first. All right. So you'll see me coming on at some times and going live with some of these questions, whether they're going to be from the ability tests or they're going to be from performance task. Just ensure that you subscribe, ensure your friends subscribe, so that whenever I come live, if I don't send out a WhatsApp message to any teacher or so, or send it out to you, ensure that you have subscribed to the channel. So as soon as I come live, you get a notification that tells you that I will be coming to do a lesson. All right. So look out for other live sessions as we explore, and we're on our way to May 26th to June 16 and June 30th. We're going to do really good in our PEP exam. All right. So now we are at the end of the session. So I hope you have taken a screenshot of what is happening here. I'm going to clear the drawings. And we're at the end. I'm encouraging you to keep practicing. Keep practicing. All right. So bye-bye, everybody. Mrs. Erskine, do you want to say anything to them before they go?
Bye, and all the best in your exam,
All
your PEP
right.
exam.
All right. Yes, we thank you for the Teachers' Day greetings. All right. So bye-bye, everyone. See you at my next live session. And a lot of you are asking about if we're having any session on Saturday. I can't say for sure no, but whenever we're having another big session, you'll definitely know before. All right. So bye-bye, guys.